Alright guys, welcome to another video on exploratory data analysis. Now in this video we'll be covering quite a lot. As usual, they will be in chunks of modules for easy digestion and understanding. Okay, so the first thing we have on our plate is what is EDA in the first place. Let's look at what EDA is. Now exploratory data analysis is an approach to analyzing data sets so that you can get to know your data first, right? You summarize the main characteristics, the shape, and all of that about the data, right? And then we can use visualization methods to explore or to start checking or finding out what is going on in our data. It is a very critical step that we cannot miss, and it helps us understand the structure of our data and the contents. We know our data. It's our gateway to data profiling. We get to know our data, what they are, what they are not, and then we start getting to discover patterns and relationships. We want to see, oh, is this column or is this particular variable making this variable behave the way it is behaving? Or for example, is marketing contributing to sales, right? Things like that. So we start looking at all of that. Then we check for anomalies and outliers, unusual things in our data. Then I'll proceed to test assumptions and hypotheses, right? All under exploratory data analysis, and then we'll prepare data for modeling, right? Because we clean, we transform, we do feature engineering, and all the rest in our data. Okay, so EDA is basically like our first time, our first date with our data, because we're asking questions, we're visualizing answers, and we are getting the guide for what to do or on what to do next. Okay, so yes, we'll just jump into it. And majorly, if we just take a flashback to the basic workflow of analytics or analysis, we know that the first thing is defining your objective or defining your understanding the question. It could be in form of question, objective, whatever it is. You should know what the problem is, or you should know what the goal is, right? Then you collect relevant data. When you get data are not always clean. Real world data are not always clean, so you have to prepare the data to clean it, right? It is a very crucial part, a very fundamental part, because everything depends on how well prepared your data is. Whether in machine learning or in analysis, you know already that wrong data, wrong insights, messy data, messy insights, dirty data, dirty insight. So this stage is a very key and core stage to preparing our data for whatever it is we want to do. So once we've prepared our data for what we want to do, then we can now jump into what? Exploration and analysis. Basically, we want to find out trends, pattern, we're checking how this is with this, we're summarizing values and all of that. We're understanding our data fully. Then we can now proceed to, okay, now that we know our data, can we bring in more variables? Can we bring in more columns, right? Which is feature engineering. We're creating new variables, new features, new columns. I'm still saying the same thing from existing ones to add more value to our data, right? Before we can now jump into maybe model building. We're now evaluating our model, and then we're now deploying what we have. So majorly, we'll focus heavily on 3 and 4 in this particular series, okay, for exploratory data analysis. And we'll be using libraries like NumPy, Pandas, and the rest. But before we look at that, I want us to understand the difference or the basics of a module, a package, and a library, right? So that we can have a clear distinction of it. A module is simply a single file that has, let's say, multiple functions inside that we can use. We can create a module ourselves where we create a file. We can create it as, let's say, data cleaning module where you can create a function that converts any inputs given to all uppercase, all lowercase. You have another one for title case, you have another one for cleaning messy data. You just have all of them in a single file. Then you cannot reuse them. That's basically what the module is, right? They will now have a package. Package is more of a folder. A package is more of a structure, right? The structure you give to your entire module. Now, inside a package, you can have more than one files, no doubt, right? You can have more than one files. And finally, a library is where you can have a package and a module, or put interchangeably. So let's just look at what I have here. All right, now in Python we have in Python, the primary difference is in their scale and structural organization. A module is a single file, which I've just explained. A package is a folder containing multiple modules, and a library is a broader collection of code that can include both a package and a module, right? So major difference: module a single file, package a folder, library, of course, it's just when you think of library, you think of a place where you have collection of books, right? A module can just be a page in a book, right? And a package can be the book itself, while a library can have collections of them. Now, there's a thin line between a package and a library, or yeah, let me put it that way. And the thin line is a package describes more of the structure, while a library describes more of the purpose. A package again describes the structure, while a library describes the purpose. Why am I bringing this to light? Because pandas, NumPy can be a package. You can see them as a package. If you search online, you can see things like Python packages, and then you see NumPy, you see pandas, and then you still search for Python libraries, and you still see NumPy and pandas, and you're confused. This is a common beginner confusion, right? So do not think about it too much. Just know that we have a module which can be a single file, then a package just majorly talks about the structure, while a library talks more about the purpose or the function of that particular library, or that particular library itself. So let's just do something little. I think we want to calculate the area of a square, the area of a circle, I mean. So we want to calculate the area of a circle just to use some modules before we jump into the package and libraries, right? So that we can have that progression, just maybe 2 or 3, and then we'll jump into NumPy itself. So we have a scenario here. You order the 12-inch pizza, diameter is 12, the radius is 6, right? I think with the diameter alone, we can do whatever it is we want to do, right? So we have the diameter to be 12. Now we want to calculate the area of the pizza. We know that the area is equals to pi, that's pi r squared, right? So pi r, where's the caret symbol again? This is the value, or this is the formula for calculating what's it called, a circle. So we can say diameter equals 12. Then to calculate the area, we can say, now we will need to import math as a module, because if we put in 3.14 as the value of pi, of course we'll lose some decimal precision, right? No doubt we'll lose some decimal precision, and we want to keep all the values as much as possible. Okay, so, and of course we'll also do a raise to power. We can do this mathematically, right? Considering that we have looked at what's it called at some point under operators, we look at mathematical operators. So we can just do r asterisk 2, right? So that works just fine. But in this case, we want to use the math module. So let's just import it at the top here. Just import it, import math, and then we'll execute it. So just wait, that should connect. This is the first cell executing. You say it's connecting. We should be good to go in. Yeah, now, okay. So we already have that, and we want to calculate the formula. Now, we want to calculate the area. One thing we must know is the formula will look like that's pi, right, multiplied by diameter divided by 2, right? Diameter divided by 2, then raised to the power of 2, right? So if this is what we want to calculate, how do we do it? Now that we have math, we can get pi from math. We can also get power. That means raising to the power of something from math. Remember, we did something like that as well under mathematical operator, where you have power, you can see base and exponential, just like that. So let's use the maths formula to do it. So we can say the pizza area of the pizza, that area of pizza area will be math dot. Now the beauty, again, I keep emphasizing it so that you can stick and you can learn to explore on your own, right? I can decide to just show you the nice ones and you're like, oh wow, that's amazing. You can learn it on your own, right? I'm showing you how you can begin to get better on your own. I'm not withholding that from you, right? So it's no, you can just explore. See, you have seal, you have quite a number of them. So by just using the dot notation, you can easily see all the available methods, right, inside the math module, all of them. So we can just say dot pi, and it's telling us that pi is a float, and that's all. So math dot pi, then we'll say multiplied by math dot power, right? Then here, this takes an argument. Then we'll pass in what? Our diameter divided by 2, diameter divided by 2, and then comma, the exponential value is what? Raised to the power of 2. So that is all we have. Now the next thing, or the last thing for us to do, is to what? To print our results. So let me take this out now. Print output, print results. All right, so we just say print f string the area of the pizza is pizza area, just like that. Then we can say, let's just add some square inches. All right, so we can say the area of the pizza is this. Now let's print out the results first and then see if there's a way we can do some little formatting to this. Okay, so we'll execute this. I think everything should be fine. Ooh, and you can see the decimal values we got. They are quite too long, but we want to put this to 2 decimal place. And yeah, it's possible what comes to your mind is round, right, which works. Okay, round, then you say the number of digits, 2, then we'll run this, and you see. Now the problem here is we're getting what? So let's put in 3, see if you get a difference. So you can see is because 0 is not a number, as it were. Having 0 at the end is cutting off that 0, right? So which is not bad, we can just leave it like that. but not everybody will know that it has a 0 behind it. But there is a better way to do this, right? And this is the way we'll be doing it going forward, because it's easy, shorter, and good. So all we have to do is we'll say, after we put in the area, pizza area, we'll put in dot 2, then F. We're saying the floating point should be 2 decimal place. But for us to understand this, for Python to understand this dot 2F, we need to put a colon like this. So with the colon, it understands that, okay, we want the decimal part of this to be 2 decimal place. And if we run this again, you can see how cool that is. So that is what we're getting, 2 decimal places, right? 2 decimal places. And yes, we now have our results perfectly. So that's one of the modules we have. Next module we want to look at now is the random module, right? So we import the random module up here. Okay, we have maths already, so we don't need to import any random module. So we want to pick, let's create a list of students first to be the rep. Thought I had that. So we want to create we want to pick random students to be the rep. We want to pick a student to be the rep. So say students. I think I'll just use the split method in this place. Alice, Bob, Charlie, Darwin, Emma, and Finn. Alright, so the splits, as usual, you know what this gives us. Let me just print it below so that you remember. List of students, then students. Alright, so we have list of students, then the student, right? Now let's bring this down. Oops. So let's bring this and see what it is first, so you can see the list of students. Now we want to pick one student from the entire class, right? So math is a different module. We have to import random here, not text. Okay, so change that to a code. Let's control control my to change it to a code. So math is at the top. Okay, we're under modules. So we import random. We run it. Then we can come in here and to pick a list of students, we can say class rep. Class rep will be random. As usual, once you put your dot notation, you begin to see some option that you have. You see choice, you see choices, etc., randint, seed, and the rest. So we just pick choice, right? Just selecting the students. So random.choice, then we'll pass in the students. So automatically, based on some random number generation, the lot falls on a particular student. So let's see what the student is. So say print f string, the class rep is it is, so will be is, then we'll say class rep. No, class rep, just like that. The selected, all right, selected class rep is this. So let's see what we'll get, or let's see what we'll get. Oh, Bob is the class rep. Let's run it again. Bob is the class rep. Now it's Finn. So you should know that the more we rerun this, the lot falls on someone else, because it's a random number generator on the line. We're just doing random number and all of that. So run that again. So you see it's now Alice. If we run that again, it's now Emma. Okay, so that's that about the random module. Let's look at one more before we close it. So let's start with statistics. Let's pick up the module statistics. No, not this. Change, please. Okay. Import statistics. Statistics. So that also means that since you have modules like math, like random, you can do much more powerful operations, right? Using them. So statistics, and since we have statistics, that means we can do a lot with the module as well, right? So in this case, we just want to get the list of scores. In this case, we just want to see the scores list of the students. So let's just say their test score, and then we want to have, let's say, the 5 or 90. I'm not using split because it's going to be text, and I might need to maybe write some extra code to convert it to an integer individually, right? So because it has to be an individual thing, so I might need some extra code to do that. Let's put 19. Let's put 95. Let's put 60. And let's put 100. All right. Let's put 100. So 1, 2, 3, 4, 5, 6, 7. All right. Same with the list we have up there. So let's say, for example, we want to get the average score, the median score, because we're talking statistics. That's like say mean, median, mode, basically. As we're talking statistics, let's just say mean is the same as average, by the way. Average score, median score, or middle score. Middle score makes more sense. Middle score, and mode, or most common score, something like that. It's just add score to it. So for the average score, we can simply do statistic. That means now, literally, if we were to do this ourselves, it will be a sum divided by the count of numbers, right? So, but with statistics, we can just do a mean directly. So say statistics dot, and then you see all that we have. You can see we have mean here. I'll pick the mean and say test score. Okay, test score, just like that. Okay, so we want to have the statistics again. Statistics. Let's wait for it to show. Okay, then we'll pick the median. Then we'll pass in the test score again. And for the last one, I want to say statistics again. Statistics dot mode. Then we'll pass in the test score again. All right. Now let's print the three of them down here. So we'll say print f average score. So yeah, let's copy this. Oops, I copied an empty space. Same. Ctrl C, Ctrl V, Ctrl V. Bring all of this up. So this will be median score or middle score. And this will be most frequent score. Most frequent score. Let's make this capital F, most frequent score. Okay, so here we'll pass in average or AVG score. All right, here we'll pass in middle, and here we'll pass in most common. All right, so this is what we'll have, and let's run them. Statistics is not defined. Okay, let me run this cell. Now let's run that again. Okay, so you can see we have average score to be 85. We have the middle score to be 90 and the most frequent score to be 90. That means 90 appeared more than once. See, 90. Now average is basically more like the middle point, right? The sum of everything divided by the number, the count of everything. So this is 100 plus 60 plus 95 plus 90 plus 75 plus 90 plus 85 divided by 1, 2, 3, 4, 5, 6, 7. So that is average. Now middle score happens when you sort this list, what falls in the middle. So if we sort this list, that's 75, 85, that's 60 first, then 75, then 85, then 90, 90, then 100. So basically it's going to look like this when we sort it. That's 60 comma, so you see 60 comma 75 comma 85, then 90 comma 90 comma 100. This is not complete. This is 1, 2, 3, 4, 5, 6. So what am I missing? 85, 90, 70, 95, right? So 95. And you can see if we check, this is the first 3, this is the last 3. So this is the middle of this, all right? And finally, the mode, the one that appears most, that's 2. That's 90, appeared twice. Okay. So that's just what we have. And we have seen another module. Let's look at one more. Let's look at one more, which is the datetime module. And then we'll wrap it up from there. All right. So say from datetime import datetime. All right. So execute this. Now that has been executed. Okay. And you're probably thinking, so far we've been importing statistics, import random, import math, but when we are importing data, which is one of the reasons I wanted to show you, is what you're doing import datetime from datetime. Well, sadly, the module and the method inside it have the same name, right? We have a datetime inside a datetime, so that we avoid, when we're writing, we avoid things like datetime dot datetime. Now you can see we're not seeing datetime anymore. So if we imported just datetime, we would have done datetime dot whatever it is we want to do. So that's going to be a long thing to do, right? That's how I just imported the datetime itself from the datetime. Okay, so the first thing I want to do is let's say now I want to grab the current moment, the time. So datetime, just in Excel, but in Excel we just use now, right? Today and now. So I want to print that out. So what should we call, what should we add? Let's just say raw date format, raw date format. Then we can put in since we're already using our formatted string, we can just do now. Okay, so the output will be showing in year, month, day, and the timestamp. Okay, that's what it's going to show. Then the next thing we want to do is, so that's just to test. So let me just leave that there. Let me make it together with this. So now the formats it will appear is not a format that we might maybe like or understand very well, maybe for people who you're showing it to. So I've already put out the codes for you. To get the month name, use the percentage with B for month name, percentage with D for day, percentage with year for Y. Then this is percentage for I, percentage I colon percentage M colon percentage I colon percentage M, then space percentage P, so that you can get a 12-hour clock time. But let's see how that really works. So we'll say clean time equals to now, right, the existing one. Then we can say string, right, formatting the raw date properly. Then we'll open the bracket and close it. Then you can see examples of what we have. So it's nothing serious. You can see example, we can just do a month, day, and year. That's percentage D, percentage M, percentage Y, and then hour, minute, and seconds. You can just do this, right? You can just do it. But let's see the way we want to do ours. Open the quotes, percentage B, then percentage D, small d, then we want a space, then percentage Y at percentage I colon percentage M percentage P, small p. All right, so this is what we want for ours. Then finally, we want to put the output right here. We'll say print, that's the final version of the clean date. We can just say formatted date, or formatted format, no, formatted date. Formatted date is clean time. Okay, we didn't start with our F, so put the F back. And yes, this is what we have. So we should see a nicely formatted date. Okay, nicely formatted date. So if we run that, okay, runtime disconnected. It's reconnecting now. All right, you can see that we now have this well formatted. Well, this is by 1 hour, right? This is minus 1 hour the current time, by the way. So that 1 hour or 2 hours. All right, so the next thing to do is let's use the date time more before we leave it. Okay, let's use the date time more before we leave it. So we can get today, which is datetime.now, and then we set a deadline, right? So today can be datetime.now. Then we can set a deadline, right? And set a deadline. So let's just say we want to see, let's say we have a goal, right? And we're setting a deadline now, how many days before we achieve it. So we can say date time, and then we can put in the year. Let's say this year, put 2026. Should we use December? Not necessarily. So let's say 06, and then let's say 30th. So this is the deadline, or let's say 27. Now we want to do a time difference or date difference. So say time remaining or days or remaining days. Underscore days. That will now be deadline, because that's in the future, minus today. So finally, we want to say f string, you have, okay, so you have remaining days dot days left to finish your project. Okay, so let's print that. Yeah, and that is how you get the number of days left. You can see this is 11 instead of the time delta we had before. Now getting it properly as 11. All right, just before you go, I have one more thing for you. All right, let's go back to the basic module and let's collapse example. And yeah, more on modules. Now here I have some created list for you. So for modules that has to do with operating system, right? See, for OS, you just import OS. So this is the module itself that you import, and is anything that has to do with your operating system. See, and I've listed them for you. Get working directory. It says get the working directory, list the files in the directory, create a new folder. If you're familiar, if you use Linux, this you're probably good with all of these, or if you use command line. So if you're not, or if you don't, you can learn them. They are easy, just like this. You do little things. Try to use this, paste, copy and paste a file path on your PC, paste it in there, see what it is, or you're using a file, try to get it. So you see you can combine paths safely. For example, you want to combine, let's say you want to create a new folder for someone. So you're saying this file, combine it, join it, right? You already know join it with this new name, things like that. We cannot go through all of this, right? But I just have the list here for you to look at, right? So you can see lists the line arguments passed to a script, exist a script safely, lists dictionaries where Python look for modules, list directories, I mean, where Python check for modules. See the math function, you can see you have the square root, you have the ceil, you have the floor, you have the power. These are the methods. We have more inside them, for example, like the pi, the ones that hold value. Under random, you have randit, random choice, random shuffle, random. You can see this generates between 0 and 1. Consider this rand in Excel, right? Consider this rand in Excel. Consider this rand between in Excel, right? So this is what we have. You have the date time. So those different things. You have the JSON handler. You have the regular expression, and you have the ones for HTTP requests, right? So feel free to explore them. You can pause the video. You can see, pause the video, take some notes, explore them one after the other. Explore them one after the other, explore them one after the other. So when you're watching, you can just pause the video and then you grab them for yourself. Okay, all right, I'll see you in the next one.